Today for e-learning on Tuesday, September 1st, I want you to complete the following assignments. Start with your warm-up. Today, your warm-up asks, what is the difference between contact and non-contact force? Do not make that more difficult than what it needs to be. You know what contact is, you know what non-contact means. So use those prefixes or the prefix for non-contact to help you out there. Don't miss that on your vocab quiz on Thursday. After your warm-up, take notice of the lab that we are completing here in class. I'm not going to make you complete this, but I still want you to take a look at it. Today in class, we are using spring scales. What spring scales are used for are to figure out how many newtons, which newtons are used to measure force, is required to drag different objects. In this case, in class, we're dragging blocks across different kinds of surfaces being just the regular tabletop, across a wash rag, across cardboard, across the tree stump that I have here in the room. So those are different surfaces that are going to require different amount of force to drag that same block with the same mass across it. Why is that? Because of friction and the different amount of friction that is on the surface of each of those different surfaces. Okay? I'm not going to make you come to school and come get the spring scale as well as this worksheet. I just want you to take a look at what we are doing. However, what you are going to be completing is the following. So you need to click on Forces and Motions Simulation. Click on this link. Also, if you take a look at the e-learning Tuesday, September 1st, it tells you the steps on what you need to do. But I'm going to just show you here as well. So click on friction because that's what we are testing today in class. And I want you to click on each of these. You don't need to worry about speed yet. We will talk about speed next week. Now, I want you to change this bar to lots of friction. So if you think about lots of friction, think about in real life, what is it that we would want to increase the friction for? An answer might be on the roads. Whenever there's icy roads, we want to increase the friction so then the cars aren't sliding all over the road. Now, I'm going to try and push this box here to the right. Notice how many newtons it takes. Right here, you see how 95, 118, 133 next to the green arrow. That is the amount of force in newtons it takes for me to push that box to the right. And the applied force is 321 newtons. And the friction force pushing back on it was 188. If I go back the other way, notice the friction force depends on the surface. Now, go ahead and stop that. Now let's change it to none and take notice of the difference. See how it changed to ice? Now we don't have any force, any newtons pushing back the opposing force. So it's really, really easy for you to slide that across. An example might be if you want to rearrange the furniture in your bedroom, if you want to slide your bed to a different part of your bedroom. If you have hardwood floors, it's going to be much easier with much less friction to move that bed than it would be if you have carpet. Okay, this is the same idea here. So I want you to just mess with that. You can change this as well. So if you want people to be sitting on each other or put trash can on top of here, and then you can push them because they are going to be different weights. So I want you to just mess with that. Take a look at the difference here if I add friction versus if I have no friction at all. And that's all I need you to do. You do not need to email me anything. I just want you to take notice there. Let me know if you have questions.